Hi friends, myself Dr. Sandeep Jagdale, working as Assistant Professor at Filtration College of Engineering. Dear friends, today we are going to discuss the water technology topic from the engineering chemistry course, and in that we will discuss today introduction, impurities present in water, the techniques used for the removal of these impurities from the water, hardness of water, and EDTA method to determine the hardness of water. So let us begin, dear friends, with this topic. Now, dear friends, the water is the gift given by the nature to the human being. And without water we can't survive. For all the processes, biological reactions, for all the living things, the water is essential. Without water, living things cannot be survived. So, what is the importance of water? It is used for the domestic purpose as well for the industrial purpose. So domestic water is used for the drinking, cooking and personal hygiene, while industrial applications include cooling, cleaning, processing and power generation in various manufacturing sectors. But both are essential, with domestic use focusing on household activities and industrial use supporting production and infrastructure. So, what is the purpose of this unit, my dear friends? Why are we going to discuss this? Because as an engineering student, you must know what are the applications of water in its solid, liquid, and gaseous form, and to make aware the students what are the impurities present in water and what are the techniques used for the water purification, so that we will convert the impure water into pure one. Let us start the structure of water molecule. You know, water has a formula, or water molecule has a formula H2O, which consists of two hydrogen atoms and one oxygen atom joined by the polar covalent bonds. This polarity gives water unique properties like being a universal solvent, having a high boiling point due to hydrogen bonds. So this hydrogen bonding present in the water molecule make it a awesome solvent, and hence it is called as universal solvent. And the water not only in the liquid form but also in its solid form and also in its vapor form, it is play an important role in the industrial field. Now, friends, nature gifted us the pure water, but its journey, the journey of water, rainwater from its sky towards the earth, the different impurities enter into the water, and when that water come on the earth during its journey on the earth, different impurities enter into the water, and in that way the pure water get impure. Now, what are the impurities present in the water? Dear friends, these are the impurities present in the water, such as suspended impurities, colloidal impurities, dissolved impurities, and biological impurities. How these impurities enter into the water and how these impurities can be removed from the water. First, suspended impurities. This type of impurities has the size of particles greater than 1000 angstrom unit, and these are visible by the naked eyes. The particles like soil, sand, organic waste, they causes the suspended impurities. But dear friends, this impurity can be removed by easiest method, that is the filtration or sedimentation or settlement. Second impurity, colloidal impurities. Colloidal impurities, it consists of the organic and inorganic matter of the size 10 to 1000 angstrom unit, and these are the colloidal particles which makes the water turbid. So these impurities, colloidal impurities, can be removed from the water by coagulation followed by the sedimentation or filtration. Here, some coagulating agents such as ferrous sulfate, alum, pulse fluor, sodium aluminate, and aluminum sulfate can be used for the removal of colloidal impurities. Third impurity, dissolved impurities. The dissolved impurities contains the two types of impurities. One is the dissolved gases and dissolved salts. The dissolved gases, dear friends, when the rainwater start its journey from sky towards the earth, it enter into the atmosphere, and atmosphere contains different gases. These gases dissolve into the water, and they become a dissolved impurities in the water. When that water come on the earth, then it passes through the different soil, different rocks and salts. which are made from the salt, and that salts get dissolved in that acidic water, and in this way the dissolved salts enter into the that salts enter into the water, and they causes the dissolved impurity. These dissolved impurities from the water can be removed by using the chemical treatments, mechanical deaeration method for the removal of dissolved gases, and we make the water free from dissolved impurities. The last impurity is the biological impurities. It includes the bacteria, algae, fungi, and other small-sized aquatic animals which causes the biological impurity. Dear friends, these impurities can be removed by sterilization or by use of certain chemicals such as bleaching powder, sodium hypochlorite, chlorine, chloramines, ozone, and also by physical methods by using the UV light, we also sterilize the water. So, dear friends, these are the impurities present in the water, and we also discuss the removal methods for its removal. Next, we have to analyze the water sample to check the quality of water, because water which is rich in the impurity cannot be used for either drinking or industrial purpose. The acceptable levels of impurities in the drinking water for industry and for the domestic as well is fixed by the international standardization agencies such as WHO and ICMR. So, in order to determine the suitability of the water for drinking or industrial purpose, the given water sample has to be analyzed for its impurity level. And hence, the chemical analysis of water is an essential parameter in water resource management. Hence, to determine the quality of water and to check the acceptable levels of impurities present in the water, we have to analyze the water sample for its quality. Here in our syllabus, we are going to discuss the two analyzing parameters such as hardness of water and alkalinity of water. Now, what is hardness of water? Roughly, we can say the salts which are present in the water, different types of salts present in the water, their concentration is called as the hardness of water. Now, you know what is the cause of hardness of water? As we discussed earlier, rainwater during its journey towards the surface of the earth absorbs CO2 from the atmosphere and forms the carbonic acid. That water becomes acidic. The reaction indicates, or it more explains how the CO2 gets dissolved in the water to form the carbonic acid. This water, acidic water, flows over the rocks through the soil containing Ca2 plus and Mg2 plus carbonates. These carbonates react slowly with the carbonic acid in water and forms bicarbonates. So reaction better explains the above sentence. CaCO3 plus H2CO3, it forms the calcium bicarbonate, similarly magnesium bicarbonate, and they are highly soluble in water. And these bicarbonates are which are highly soluble in water, they causes the uh, temporary hardness to the water sample, and they causes the hardness to the water sample. Along with the bicarbonates, chlorides, sulfates, nitrates, they are also get soluble in the water, and they causes the hardness to the water sample. So we can define the hardness of water sample as the soap consuming capacity of water is called as a hardness of water. Why determining the definition, or why determining the definition of this hardness in terms of soap consuming capacity? Because you know, my friends, the impurities present in the water, when we are using the soap for the cleansing purpose in the water, the soap react with the impurities salts present in the water, and hence the cleansing activity of the soap gets decreased, and there is a less formation of lather, and hence the consumption of soap in such water for the cleansing purpose increases, and therefore we can define more the hard water, more is the consumption of hardness, more is the consumption of soap, and hence we can define the hardness in terms of the soap consuming capacity of water is called as a hardness of water. There are two types of hardness of water: temporary hardness and permanent hardness, that we will discuss in the coming slide. Before that, we discuss the what are the units of hardness, how we express the hardness in terms of CaCO3. Why? The hardness of water is always expressed in terms of calcium carbonate equivalent, because calcium carbonate is actually insoluble in water as compared to other salts, and its molecular weight is average 100, and it is easy to calculate to determine the hardness of water sample in terms of CaCO3 equivalent of other salts. So the quantities of chemical impurities present in the water can be calculated in terms of CaCO3 by the formula mgCaCO3 equivalent of any salt is equal to weight of that chemical in milligram, maybe, into 50 divided by equivalent weight of that chemical. This formula can be modified in this way the weight of that chemical into 100 divided by molecular weight of that chemical. Here 100 is the molecular weight of CaCO3. We also express the hardness in terms of ppm, that is parts per million CaCO3 equivalent. It can also express in terms of ppb, that is parts per billion CaCO3 equivalent. So hardness can be expressed in a different way. These are the units of hardness. This is a comparison between the hard water and soft water. Hard water means which contains the dissolved salts. There it is called as hard water, and soft water is one which does not contain the dissolved salts. So how this affect the quality of water? See, hard water does not produce lather with the soap solution on shaking or on rubbing. On the contrary, the soft water produces the lather with the soap solution on shaking or on rubbing. Hard water contains dissolved salts of calcium and magnesium. Contrary to that, the soft water does not contain the dissolved salts of calcium and magnesium. Due to the presence of these salts in hard water, the cleansing quality of the soap is depressed. Cleansing quality of the soap is not depressed in the soft water because absence of dissolved salts. Boiling point of the water is elevated, so there is a wastage of time and fuel in the hard water. In other contrary, boiling point of the water is not elevated in the soft water. So these are the impact on the quality of the water due to presence and absence of the salts in the water. Here, these are the types of hardness. As we discussed, hardness is of two types. One is the temporary hardness and second is the permanent hardness. What is the temporary hardness? It is also called as carbon hardness and it is also called as alkaline hardness. Hardness due to the presence of bicarbonates of calcium, magnesium and carbonates of Fe2 plus or heavy metal ions is called as temporary hardness. The temporary itself indicates, the name itself indicates these salts are temporarily present in the water because this type of hardness can be easily removed from the water by just boiling the water. When bicarbonates are decomposed, yielding insoluble carbonates or hydroxides, which are deposited as a crust at the bottom of vessel. So see the reaction, my dear friends. Calcium bicarbonate undergoes decomposition on heating or by boiling this. At boiling temperature, this calcium bicarbonates are converted into CaCO3, which is insoluble in water, along with the formation of H2 and liberation of CO2 gas. Similarly, the magnesium bicarbonate undergoes to form the magnesium carbonate. Similarly, they form the magnesium hydroxide, which is a precipitate, and there is a formation of there is a removal of this salts get precipitated at the bottom of the vessel, and we can just filter it, and this water get free from the hardness causing or temporary hardness causing salts. So alkaline hardness is due to the presence of bicarbonates and carbonates and hydroxides of the hardness producing metal ions, as we discussed, and this can be determined by the titration with the HCl by using the methyl orange as an indicator. So this is about the temporary hardness. What is permanent hardness? The hardness of the water sample, which is due to the presence of dissolved chlorides, sulfates and nitrates of calcium, magnesium, iron and other heavy metal ions, is known as a permanent hardness. The salts responsible for the permanent hardness are chlorides, nitrates and sulfates of calcium, copper, magnesium, aluminum and other heavy metal ions. Examples are given here. But the permanent hardness cannot be easily removed like boiling. By boiling, like temporary hardness, it cannot be removed by just boiling. It requires some chemical treatments to remove the permanent hardness from the water. So this is about the permanent hardness. You may have the discussion, or you may compare yourself what are the distinguishing point between the temporary hardness and permanent hardness. As a for the better understanding, you can have these comparative points. So total hardness can be written as a temporary hardness plus permanent hardness. Okay, so let us discuss how to determine the hardness of water sample. The hardness of water sample is determined by using the EDTA method. EDTA stands for ethylene diamine tetraacetic acid. This is a complexometric titration because when we add the EDTA from the burette into the metal ions of the water sample, then there is a formation of complex. Hence, this titration is called as a complexometric titration. Here is the outline of the process of EDTA method, the titrant, pH. So before going to discuss the whole EDTA method, I will explain Why the EDTA is used for this determination of hardness, why the pH is maintained between 10 to 11, and why there is a use of buffer solution, that is to maintain the pH. So disodium EDTA actually we use in the titration instead of EDTA because EDTA is partially soluble in water while the disodium EDTA is highly soluble in water. EDTA molecule has a 4 carboxylic acid groups and 2 nitrogen atoms with lone pair of electrons, hence it acts as a hexadentate ligand. And why pH is maintained at basic side? Because the one addition of EDTA method, there is a formation of H plus ions and that decreases the pH, hence to maintain the pH on the basic side, buffer solution of pH 10 is added to get the sharp color change. The reaction between the disodium EDTA and the heavy metal ion results in the formation of cyclic coordination complex, that is a chelate we can say, and hence this is called as a complex symmetric titration. Yes, so in the procedure actually there are 4 steps are there, and in the first part you have to determine the concentration of disodium EDTA, that is the standardization of disodium EDTA. Second, determine the total hardness of water sample. Third, determination of permanent hardness of the water sample, and last, determination of temporary hardness of the water sample. So in the standard procedure, first you have to standardize the disodium EDTA with the help of MgSO4 or zinc sulfate in the conical flask, and then you have to add the disodium EDTA from the burette into the MgSO4 solution, for example, which is wine red color. Then titrate that till wine red color changes to sky blue. Stop the titration and calculate the molarity of disodium EDTA. Further, the same procedure you have to apply. The change is that in the conical flask you have to take the water sample from which you have to find out the hardness. Into the same water sample you have to add 5 to 10 ml of buffer solution, basic buffer solution, then add 3 to 4 drops of erythrome black indicator, color becomes changes to wine red. Titrate this wine red color solution with the EDTA from the burette till color changes to sky blue. That is the end point. Note down the end point. Take the 3 readings and consider the average burette reading. Then take 3 readings and consider the constant burette reading. This will help you to calculate the total hardness. Now to calculate the permanent hardness, you have to use the same water sample but after boiling and cooling. Take that cooled water sample and apply the same procedure. In that case you will find out the permanent hardness, and you know total hardness is equal to permanent plus temporary. So here we can find out the temporary hardness is equal to total hardness minus permanent hardness. So to determine the hardness, the formula is there. The total hardness is equal to Y into Z upon V into 100 into 1000 ppm CaCO3 equivalent. The same formula is there for to determine the permanent hardness, but here you have to consider the burette reading. For total hardness, the first burette reading without boiling you have to consider. For permanent hardness, after boiling, burette reading you have to consider, and to calculate the temporary hardness, total minus permanent, you can calculate the temporary hardness. So in this way you can find out the total hardness from the water sample by using the EDTA method. So my dear friends, if any doubt you have, you can comment me, and if you like my video, suggest to your friends and subscribe my channel. Thank you.